Hello everyone. In today's video, we are going to look at a very beautiful geometrical visualization of a relatively hard physics problem. So the problem is, in a river bank from one shore, a man can swim at speed u in a still water with respect to ground, and here the velocity of river is v. So he wants to move to that middle line, but because of velocity of river, it shifts its position. So if the angle is theta from the vertical, what should be the value of theta so that the drift will be minimum and the velocity of river is greater than velocity of man? Why this condition? We will see it later. So let's look at how to solve it. We want drift minimum, so it is obvious he will swim in opposite direction of the velocity of river. So let's say he swims at an angle theta from vertical, and if we resolve the vector of velocity of swimmer in vertical and horizontal components of u cos theta and u sin theta, and now we want drift to be minimum, and drift is formed because of some velocity in x direction. So drift, let's say drift is 0, so velocity in x is 0, which means u sin theta cancels out v, so sin theta is equals to v by u, but it is incorrect. Why? Let's see this. So using this method we get sin theta is equals to v by u, and we all know that sin theta is always less than or equals to 1, which means v by u is less than or equals to 1, or v is less than or equals to u, and that is why question said v is greater than u, which means this solution is only applicable for v smaller than u. To visualize this geometrically, you can see a GeoGebra simulation for this problem. So this length is the vector u here, and this length is vector v, which is velocity of river, and for the net velocity both the vectors are added from tail to head. So you can see that as we rotate u, the net vector also rotates and u is constant, so this point will always move in a circle. Also we can see that the drift in red color. So now we can see that as we rotate u vector, drift also changes. So let's analyze this drift. So as we make our angle smaller, drift also becomes smaller, and after some time it starts increasing. So our answer is somewhere between these 2 points, and if you will see clearly, as our resultant velocity becomes tangent to the circle, we have the minimum drift. So to find the minimum drift, the net vector will be tangent to the circle. Here you can see the image of that simulation. So if it is tangent, it will make 90 degrees from radius or u, and using a very simple trigonometry we can find that sin theta is equals to u by v, and this is our answer. Like this video if you like this solution, and tell your own solution in the comment section. Thanks for watching.